Number 10. The Deccan Traps, 66 million years ago, a wound opened in the Earth so large that geologists still cannot fully comprehend its scale. It was not a single eruption. It was not a volcano in the traditional sense. It was a continuous outpouring of lava that lasted for hundreds of thousands of years, covering an area roughly the size of modern India, with basalt flows stacking up to 2 kilometers thick in places. We call the result the Deccan Traps. You can still see them today, an enormous geological scar across the Indian subcontinent, layers of dark volcanic rock recording an era of planetary violence. The timing is what makes this event so deeply unsettling. The Deccan Traps were erupting when the asteroid hit. Or, more accurately, the asteroid hit while the Deccan Traps were already in progress. The volcanic activity was already releasing massive amounts of carbon dioxide and sulfur dioxide into the atmosphere, already stressing the global climate, already beginning to thin the food webs that had sustained life for millions of years, when a rock approximately 10 kilometers across arrived from space and ended the discussion completely. The question scientists have debated for decades is this: which one killed the dinosaurs? Some researchers argue the asteroid alone was sufficient. The evidence for impact is undeniable. The Chicxulub crater, the iridium layer found at the same geological boundary across the planet, the sudden disappearance of non-avian dinosaurs in the fossil record. But other researchers point out that the Deccan Traps were producing environmental stress for at least 200 years before the impact, and that the eruptions actually increased in intensity shortly after the asteroid hit, as if the shock waves traveling through the Earth's mantle amplified what was already happening. The current scientific consensus is that both events contributed. The volcanic winter from Chicxulub collapsed the food chains, but the Deccan Traps had already weakened them. It may have been a double extinction event delivered by both fire from below and fire from above simultaneously. What makes this event particularly terrifying is not just its scale. It is what it reveals about the relationship between geological forces and the survival of complex life. The dinosaurs had ruled this planet for 165 million years. They survived ice ages. They survived climate shifts. They survived previous extinction events. They did not survive the combination of prolonged volcanic winter and a single catastrophic impact happening within a geologically short window. The planet does not offer warnings. It does not send signals that the conditions required for your survival are about to disappear. It simply changes, and the species that cannot adapt fast enough, however dominant, however successful, however deeply evolved, are erased. Everything that came after, every mammal, every human civilization, every idea, exists in the space left behind by that extinction. We are here because they are not. Number 9. Mount Mazama, 7,700 years ago, in what is now the state of Oregon in the northwestern United States. A mountain approximately 3,700 meters tall began to die. Mount Mazama had been building for hundreds of thousands of years. It was a composite stratovolcano, enormous and visually dominant, the kind of peak that defines a landscape and becomes a cultural anchor for the people who live around it. The tribes of the Pacific Northwest knew this mountain. They built their lives around it, their stories near it, their sacred geography in relation to it. Then it emptied itself from the inside. The eruption of Mount Mazama approximately 700 years ago was catastrophic by almost any standard. It ejected an estimated 50 cubic kilometers of material into the atmosphere. By comparison, the 1980 eruption of Mount St. Helens, an event that killed 57 people, destroyed 520 square kilometers of forest, and remains one of the most documented volcanic disasters in American history, ejected approximately 1 cubic kilometer. Mazama was 50 times larger. The volcanic column reached an altitude that spread ash across the entire Pacific Northwest. Geologists today can identify the Mazama ash layer in soil samples across a vast region: Oregon, Washington, Idaho, Montana, British Columbia, a thin grey line in the earth, recording a single morning when a mountain ceased to exist, because that is what happened. The eruption was so violent, so complete in its evacuation of the magma chamber below, that the mountain could no longer support its own weight. The peak collapsed inward. An estimated 700 meters of mountain simply fell into the void where the magma had been. What remained was a caldera, a roughly 10-kilometer wide depression in the landscape where a mountain had stood. Over centuries, the caldera filled with rain and snowmelt. Today it is Crater Lake, one of the deepest and bluest lakes in North America, a strikingly beautiful body of water that is, in geological terms, a wound that never fully healed. The Klamath people of the region have oral traditions that describe an event matching the eruption of Mazama with striking specificity: a great battle between a sky being and a mountain spirit, fire from the mountain, darkness across the land, the collapse of a great peak. For generations, these accounts were treated as mythology. Geologists eventually confirmed that the dates align. The Klamath people were not mythologizing, they were remembering. Their ancestors had witnessed it. What makes this event so profoundly unsettling is the intimacy of the destruction. We tend to think of ancient geological events as distant from human experience, something that happened before anyone was watching. But people were watching. They were standing close enough to see a mountain disappear. They survived. They carried the memory for 7,000 years, encoded in story because there was no other way to preserve it. The landscape they had known, the landmark that organized their world, was gone, and in its place, a lake so unnaturally beautiful that it feels almost like an apology. The earth destroyed something sacred, then filled the hole with water and called it done. Number 8. The Laacher See Eruption. 12,900 years ago, the world was already in crisis. The last great ice age was ending, but it was not ending smoothly. The climate was oscillating, warming periods followed by sudden cold reversals, ecosystems restructuring, megafauna disappearing, early human populations scattered and stressed. The world was in a state of geological and climatic transition that would have felt, to anyone living through it, like permanent instability. Then, in what is now the Eifel region of Western Germany, a supervolcano erupted. The Laacher See Eruption, named for the lake that now sits in the remains of its caldera, was one of the largest volcanic events in European history. It ejected an estimated 6 cubic kilometers of material, sending a column of ash and gas tens of kilometers into the stratosphere. The ash fall spread across a vast region of what is now northern Europe. Evidence of the Laacher See tephra, the volcanic material, has been found in sediment cores from locations across Germany, France, Scandinavia, and even as far as the Italian peninsula. But the eruption's most consequential impact may not have been the immediate destruction. It was the timing. Researchers studying ice cores and climate records from the period have noted that the Laacher See eruption occurred at a moment when the climate was already undergoing a fragile warming. Some scientists have proposed that the volcanic winter triggered by the eruption may have contributed to, or worsened, the Younger Dryas, a sudden and dramatic return to near-glacial conditions that interrupted the warming trend for approximately 1,200 years. If that connection holds, A single volcanic event in Germany may have delayed the end of the Ice Age by over a millennium. The populations living in Europe at the time were small, mobile, and highly dependent on the animals and plants of a particular environment. A volcanic winter disrupting that environment, eliminating vegetation, killing prey animals, contaminating water sources with ash, would have pushed already vulnerable communities toward collapse. What makes this event so disturbing is its obscurity. Almost no one outside of volcanology has heard of the Laacher See Eruption. It lacks the cultural resonance of Vesuvius, the legendary status of Thera, and yet by almost any scientific measure, it was enormously consequential, a continent reshaping event that may have altered the trajectory of European climate and population for more than 1,000 years. And here is the detail that closes the door on any comfort. Laacher See is not extinct. Geologists classify it as dormant. The last eruption was 12,900 years ago. Carbon dioxide bubbles still rise from the lake. The magma system beneath it remains active. It is one of the most closely monitored volcanic zones in Europe precisely because it has not finished with us. The Ice Age ended. The supervolcano went quiet, and it is still there, still breathing, in the middle of one of the most densely populated regions on Earth. Number 7. Mount Samalas in 1257 AD. Something happened that sent a spike of sulfur into ice cores from both poles simultaneously, from Greenland in the north and Antarctica in the south. The signal was enormous. Climate scientists examining the cores recognized immediately that it represented the largest volcanic event of the last 7,000 years. But for decades, they could not identify which volcano had caused it. The eruption was so massive that its atmospheric signature dwarfed every other volcanic event in the medieval record. The sulfur deposit it left in polar ice was twice as large as that produced by Mount Tambora in 1815, an eruption we will get to, the largest in recorded human history. Whatever caused the 1257 signal was something almost beyond comprehension. For 750 years, the volcano remained unidentified. In 2013, a team of researchers published a study identifying the source as Mount Samalas, a volcano on the island of Lombok in what is now Indonesia. They matched the chemical signature of the ice core deposits to deposits on the island itself, and found corroborating evidence in a medieval Javanese text called the Babad Lombok, which described a catastrophic eruption of a mountain called Samalas that buried the prosperous kingdom of Pamatan under volcanic debris. The eruption ejected between 40 and 50 cubic kilometers of material. The volcanic plume reached altitudes of up to 43 kilometers, well into the stratosphere, where the sulfur dioxide it carried could spread across the entire planet before falling out of the atmosphere months, or even years later. The consequences were staggering. The year 1258 in Europe was one of the worst years in medieval history. Contemporary chronicles describe spring that did not arrive, crops that failed to grow, summers that felt like winters. Accounts from England describe rivers flooding in summer, grain prices collapsing because there was no grain, mass starvations spreading through communities that had no understanding of what was causing it. London saw burial records spike dramatically. One estimate suggests tens of thousands of people died in England alone. Across the Middle East, Africa, and Asia, similar records emerge. Failed harvests, famines, epidemic disease opportunistically spreading through populations weakened by malnutrition. Researchers estimate that the global death toll from the aftermath of the 1257 eruption may have reached into the millions, and no one knew why. The people who starved in English villages in 1258 did not know about Indonesia. They did not know about Mount Samalas. They did not know that a volcano on the other side of the world had injected enough sulfur dioxide into the upper atmosphere to dim the sunlight reaching their fields by a measurable percentage. They only knew that the summer had not come, that the grain had not grown, and that people were dying. What makes this event so deeply frightening is that gap. The gap between cause and consequence. The gap between a mountain exploding in Indonesia and children starving in France. There was no connection visible to anyone living through it. There was only the inexplicable failure of the world to function as expected. The volcano responsible for one of the worst humanitarian disasters of the medieval period was only identified in 2013. For 756 years, it was simply the catastrophe that no one could explain. Number 6, Santorini, around 1600 BC. The exact date is still debated among researchers, with some estimates placing it as early as 1628 BC. An island in the Aegean Sea ceased to exist. The island had been inhabited for thousands of years. The people living on it were Minoans, among the most sophisticated cultures of the Bronze Age. Skilled sailors, gifted artists, builders of multi-story structures with indoor plumbing at a time when most of the world was still constructing mud brick huts. Their civilization, centered on the island of Crete, had dominated Aegean trade for centuries. They painted dolphins on their walls and stored wine in ceramic jars and built palace complexes that required administrative systems of remarkable complexity. One of their major settlements sat on the island of Thera, on the rim of what was then a large, beautiful, populated volcanic island in the southern Aegean. The eruption obliterated it. The Minoan eruption of Thera, one of the largest volcanic events in human history, ejected somewhere between 30 and 80 cubic kilometers of material. The island did not simply erupt, it collapsed. The center fell into the sea, leaving behind the crescent-shaped remnant we know today as Santorini, surrounding a submerged caldera 9 kilometers across. The immediate effects were catastrophic. The collapse generated tsunamis estimated by some researchers to have reached heights of 35 to 150 meters when they struck the coastlines of Crete. The Minoan settlements along the northern coast of Crete were obliterated. The agricultural system collapsed. The ash fall, which spread southeast across the Mediterranean, disrupted farming across a vast region. The Minoan civilization did not disappear overnight. It declined over decades following the eruption, until it was eventually absorbed and supplanted by the Mycenaean Greeks. Whether the eruption was the primary cause of that collapse or simply a contributing factor remains one of archaeology's most contested questions. What is undisputed is that the civilization that had defined Aegean culture for centuries did not survive the century following the eruption of Thera, and there is one more possibility, one that researchers have debated with genuine seriousness for decades. The Greek philosopher Plato, writing approximately 1,200 years after the eruption of Thera, described a great island civilization that sank into the ocean in a single catastrophic day and night. He called it Atlantis. He said it was destroyed by divine punishment and swallowed by the sea. The Minoan civilization, on an island that literally collapsed into the sea in a cataclysmic eruption, an eruption that generated tsunamis, sent ash across the Mediterranean, and ended a great maritime culture, is the most archaeologically credible origin for what Plato described. What makes this terrifying is not just the destruction, it is the echoing of it. A real event was so incomprehensible, so total, so beyond the language of disaster, that the people who inherited its memory turned it into legend. And that legend outlasted Rome, outlasted the Byzantine Empire, outlasted the Renaissance. We are still telling the story of Thera. We just call it Atlantis. The island is gone. The story remains. Number 5. Mount Tambora. On the night of April 10th, 1815, the loudest sound in recorded human history detonated on the island of Sumbawa in what is now Indonesia. The explosion of Mount Tambora was heard 2,600 kilometers away. It was heard on Sumatra. It was heard by ships at sea, hundreds of kilometers from the eruption. Officers on distant islands, hearing what sounded like cannon fire, sent search parties looking for naval battles that were not happening. The eruption ejected approximately 160 cubic kilometers of material, making it the most powerful volcanic eruption in recorded human history by a significant margin. The volcanic column reached 43 kilometers into the stratosphere. The caldera that formed in the aftermath was 6 kilometers wide and 700 meters deep. 3 entire kingdoms on Sumbawa were buried under pyroclastic flows. Of the approximately 71,000 people on the island before the eruption, an estimated 11,000 to 12,000 died in the immediate event. The rest faced a landscape so completely altered that survival there became nearly impossible, but the local death toll was not the true catastrophe. The sulfur dioxide and ash ejected into the stratosphere spread across the northern hemisphere over the following months. By 1816, the atmospheric effect was undeniable. The year 1816 became known as the year without a summer. In New England, frost killed crops in June and August. Snow fell in Quebec in July. European harvests failed across France, Germany, Switzerland, and the British Isles. In China, unusually cold temperatures destroyed rice crops in Yunnan province. In India, the disruption of monsoon patterns contributed to a cholera outbreak that eventually spread into a global pandemic. In Ireland, crop failure triggered a famine that, while less catastrophic than the Great Famine of the 1840s, caused widespread suffering and mortality. Across the Northern Hemisphere, grain prices doubled and tripled. Food riots erupted. Refugees moved across Europe, searching for food in regions that had no more food to offer. Historians estimate the global death toll from the Tambora famine at somewhere between 70,000 and 200,000 people, numbers so large they still stagger, and in a villa on Lake Geneva, in the cold and sunless Swiss summer of 1816, a group of writers and poets, sheltering from the relentless rain, held a ghost story competition to pass the time. Mary Shelley, 18 years old, wrote a story about a scientist who created life and could not control what he had made. That story became Frankenstein, a novel about the terror of natural forces beyond human understanding, written in the shadow of a volcano the author had never heard of. What makes Tambora so disturbing is its modernity. This was not the ancient world. This was 1815. This was the era of Napoleon, of the Industrial Revolution, of a global trade network, of newspapers and postal systems, and governments with the capacity to organize responses to disaster. And still, the famine spread. Still, the death toll climbed. Still, the people starving in European villages did not understand why the summer had not arrived. Modern civilization, at the height of its early industrial power, looked at the sky and had no answer. If Tambora happened tomorrow, we would know why within days. We might even be able to predict it. What we could not do, what no civilization in history has been able to do, is stop what comes after. Number 4. The 536 AD Mystery Eruption. Historians and climate scientists have called 536 AD the worst year to be alive in the last 2,000 years. Not 1349, the year the Black Death was at its most catastrophic peak. Not 1918, the year of the Spanish flu pandemic. Not any year of the 20th century, with its wars and genocides and industrial destruction. 536 AD. In that year, a mysterious fog, not fog in the meteorological sense, but a persistent dry haze, the kind produced by volcanic aerosols suspended in the upper atmosphere, appeared across Europe, the Middle East, and parts of Asia. Contemporary accounts are unmistakable. The Byzantine historian Procopius wrote that the sun gave light without brightness, like the moon, for 18 months. The Roman politician Cassiodorus wrote letters describing a year without seasons, a sun that cast no shadows at noon, a frost that would not leave. Crops failed. Temperatures dropped. In China, snow fell in summer. In Peru, ice began to form on glaciers at unusual rates, a signal preserved in ice cores that climate scientists have since documented. The world did not warm again for approximately a decade, and in those years of cold, hunger, and disruption, the conditions were created for what came next. In 541 AD, the plague of Justinian emerged, the first great bubonic plague pandemic in recorded history, killing tens of millions of people across the Byzantine Empire, the Mediterranean world, and beyond. Researchers have argued that the famine conditions created by the volcanic winter of 536 weakened immune systems, disrupted trade networks, and concentrated desperate, malnourished populations in conditions where disease could spread with terrifying speed. The volcanic eruption that caused the 536 event has never been definitively identified. Ice core analysis places a large eruption in the northern hemisphere sometime in 535 or 536 AD. Researchers have debated candidates, including a volcano in Iceland, a caldera in North America, and sources in the tropics. The mystery persists. A catastrophe with a global footprint documented by eyewitnesses across 3 continents, triggered by a geological event whose location remains uncertain 17 centuries later. What makes 536 particularly terrifying is the invisibility of the mechanism. Procopius did not understand why the sun had dimmed. Cassiodorus did not know about stratospheric aerosols. The farmers watching their crops fail in the cold summer of 536 had no framework to explain what was happening. They saw the sky change, and they experienced the consequences, and they had no way to connect those two facts. 536 AD is a date that should be more famous than it is. It is the year a volcanic eruption began a sequence of events: volcanic winter, famine, plague, empire collapse, that killed millions of people, accelerated the fall of the Eastern Roman Empire, and reshaped the political map of the known world. The eruption probably lasted hours. Its consequences lasted centuries. Number 3. Hunga, Tonga, Hunga, Haʻapai. On January 15, 2022, the most powerful explosion ever recorded by modern scientific instruments detonated beneath the surface of the South Pacific Ocean, approximately 65 kilometers north of Tonga's capital. The Hunga Haʻapai submarine volcano erupted with an energy release that scientists estimate at somewhere between 4 and 18 megatons of TNT equivalent, several times the yield of the most powerful nuclear weapons ever tested. The pressure wave from the explosion circled the Earth 4 times, detectable by barometric sensors on every continent. The eruption was heard in Alaska, more than 9,000 kilometers away. In New Zealand and Fiji, the sonic boom rattled windows. Satellites captured imagery of the eruption column reaching 57 kilometers into the atmosphere. Higher than any other eruption in the satellite era, higher than any other documented eruption in decades, the tsunami it generated crossed the entire Pacific basin. Waves struck Tonga, destroying coastal communities on multiple islands. Waves reached Japan, the United States, New Zealand, and as far as the Caribbean. In Peru, Two people drowned in waves generated by an eruption that occurred on the other side of the ocean, and then it was over. The eruption lasted a matter of hours. By the next day, the world had moved on to discussing other things. This is the number that does not belong on a list of ancient events. This is the number that happened while you were alive. Most people reading or watching any documentation of this event remember the news coverage. They remember the images. They remember the satellite footage of the ash cloud expanding across the Pacific like a slow, grey flower. What most people do not fully remember, because the coverage moved quickly, because Tonga is small, because no major power was directly threatened, is what the scientific community said in the weeks and months following the eruption. They said we got lucky. The Hunga Tonga eruption, for all its extraordinary power, was relatively brief. Its sulfur dioxide injection into the stratosphere, while significant, was smaller than researchers expected given the energy released, because much of the eruption's energy was absorbed by the ocean water above it. If the volcano had erupted in a way that maximized its atmospheric injection of aerosols, the climate impact could have been considerably more severe, and the volcanic system that produced the 2022 eruption remains active. What makes this entry so specifically frightening is not the scale of the 2022 event. It is the reminder we are not done with volcanoes. Volcanoes are not done with us. The most powerful explosion in living memory happened in 2022, was heard across the Pacific, circled the globe 4 times as a pressure wave, and was largely forgotten within a news cycle. The systems that produce these eruptions do not operate on human timescales. They do not speed up or slow down based on our attention. They run on geological time, and on geological time, the 2022 eruption was simply the latest data point in an ongoing process. The next one will come. It always does. Number 2. The Campanian Ignimbrite. 39,000 years ago, a supervolcanic eruption occurred in what is now the Phlegrean Fields, the Campi Flegrei, west of modern Naples, Italy. It is called the Campanian Ignimbrite eruption, and it is the largest volcanic event in Europe in at least 200,000 years. The eruption ejected approximately 300 cubic kilometers of material. Pyroclastic flows, superheated clouds of gas, ash, and rock moving at speeds of hundreds of kilometers per hour, spread across an enormous area. Ash from the Campanian Ignimbrite has been found in sediment and ice cores across a vast region of Europe, the Middle East, and the Eastern Mediterranean. The tephra layer it deposited serves as a geological timestamp, a horizon marker so widespread that researchers use it as a reference point in stratigraphy across the entire region. The climate impact was severe. The eruption injected enough sulfur dioxide into the atmosphere to trigger a significant volcanic winter across Europe and Western Asia, with estimated temperature drops that some researchers place at several degrees Celsius, lasting years to decades. Now consider who was living in Europe at the time. 39,000 years ago, Europe was home to 2 species of human. Modern Homo sapiens had been expanding into the continent from Africa and the Middle East over the previous several thousand years, and Neanderthals, the hominid species that had inhabited Europe and Western Asia for at least 400,000 years, were still present, though their populations were already in decline. The Campanian Ignimbrite eruption occurred at a moment researchers identify as critical in the Neanderthal extinction timeline. The Neanderthals disappeared from the fossil record within approximately 5,000 years of the eruption. Some researchers have proposed that the volcanic winter caused by the eruption devastated the ecosystems that supported the Neanderthal population, destroying their prey animals, eliminating their plant food sources, and pushing populations that were already fragile past the threshold of recovery. The hypothesis is debated. Some researchers argue that Neanderthal decline was already well underway, driven by competition with and interbreeding with modern humans. Others argue that the volcanic winter was the decisive blow. The truth may be somewhere between those positions. A species already stressed by competition and population decline, struck at its most vulnerable moment by a continental-scale environmental catastrophe. What makes this entry so profoundly disturbing is what it implies about intelligence, adaptability, and survival. The Neanderthals were not primitive. They used tools. They buried their dead. Evidence suggests they created art and wore pigments. They had survived multiple ice ages over hundreds of thousands of years. They were not fragile or unsophisticated, and they may have been destroyed, finally, definitively, not by war, not by disease, not by any failure of their own culture, but by a supervolcano erupting in Italy, the most successful hominid in the history of Europe before our own species. The occupants of this continent for longer than civilization has existed may have been erased by fire from the earth beneath their feet, and the same volcanic system that produced the Campanian Ignimbrite eruption 39,000 years ago is still there. The Campi Flegrei remains one of the most closely monitored volcanic zones in the world. Sitting beneath the city of Naples and the surrounding region, home to more than 600,000 people, it has been showing signs of unrest, ground uplift, increased seismic activity for decades. Scientists monitor it constantly. It is not extinct, it is resting. Number 1. Toba. 74,000 years ago, the Earth detonated. The Toba supervolcanic eruption, which occurred on the island of Sumatra in what is now Indonesia, was the largest volcanic event in the last 2 million years. It ejected an estimated 2,800 cubic kilometers of material, an almost incomprehensible volume. To put that number into perspective, the 1980 eruption of Mount St. Helens, which we have already noted as a benchmark of modern volcanic disaster, ejected approximately 1 cubic kilometer. Toba ejected 2,800 times that volume. The pyroclastic flows covered enormous areas of Sumatra. Ash fell across the Indian subcontinent in a layer that, in some locations, was estimated to be several meters thick. Ash from Toba has been found in sediment cores from the Arabian Sea, from Lake Malawi in East Africa, from marine cores across the Indian Ocean. A layer of grey in the geological record stretching across an entire hemisphere, deposited in days by a single event. The atmospheric injection of sulfur dioxide from Toba triggered what researchers have termed a volcanic winter of extraordinary severity. Estimates of global temperature decline vary. Some researchers suggest drops of 3 to 5 degrees Celsius. Others propose drops of up to 15 degrees in higher latitudes, but the duration of the impact is estimated at years to possibly decades. Plants died, animals starved, ecosystems across Africa, Asia, and Europe restructured or collapsed, and here is where Toba becomes something more than a geological event. Here is where it becomes a story about human survival at the most fundamental level imaginable. Genetic studies of modern human populations have revealed something that took decades to explain. Humans are extraordinarily genetically similar when compared to other species of similar geographic range and population size. Chimpanzees, confined to equatorial Africa, show more genetic diversity than 7 billion humans spread across every continent on Earth. This low genetic diversity is a signature, a fingerprint in our DNA, of a population bottleneck. At some point in the past, the human population was reduced to a very small number of individuals. And all humans alive today are descended from those survivors. The timing of the Toba eruption aligns with the period geneticists identify as the human bottleneck. Some researchers have argued that the Toba catastrophe reduced the global human population to somewhere between 10,000 and 30,000 individuals. Other researchers dispute this, arguing that human populations in Africa may have been partially sheltered from the worst effects and that the bottleneck may have multiple causes. The debate continues. What is not debated is that the genetic evidence for a severe population reduction in our species' past is real, and that Toba represents the most plausible single catastrophic cause within the relevant time frame. Think about that number. 10,000 people. At the height of Toba's aftermath, there may have been fewer humans alive on this planet than fit in a moderate-sized sports stadium. A species that had already spread from Africa into the Middle East, into southern Asia, that had survived hundreds of thousands of years of climatic instability, reduced to perhaps 10,000 individuals. Every person alive today is descended from those survivors. Every civilization, Sumerian, Egyptian, Greek, Roman, Chinese, Mesoamerican, everyone, was built by the descendants of people who made it through the Toba catastrophe. Every language, every religion, every scientific discovery, every work of art ever created by a human being, all of it traces back to a population that may have been small enough to fill a single city block, holding on in scattered refuges while the sky was dark and the world was starving, and the volcano that had nearly erased them continued to cool the air above the continent. What makes Toba the most terrifying event on this list is not its size, though it was the largest volcanic eruption in 2 million years. It is not its duration, though the volcanic winter it triggered may have lasted for decades. It is the fact that it almost worked. Whatever combination of factors allowed those final thousands of humans to survive, whether it was geographic luck, dietary flexibility, technological ingenuity, or simply the statistical chance that a few groups were in the right locations, it was close. Genuinely, existentially close. Humanity is not the inevitable outcome of evolution. It is not the guaranteed product of a planet that was always going to produce intelligent, civilization-building, story-telling creatures. It is the result of a catastrophic narrowing, a near extinction. 74,000 years ago, on a planet that was perfectly willing to let us go, the volcano did not negotiate. It did not weigh the value of what it was destroying. It erupted because the geological conditions required it to erupt. We survived because of reasons we still do not fully understand, and the magma systems that generated Toba are still there beneath Sumatra. The supervolcanic hotspot that produced the largest eruption in 2 million years has produced multiple large eruptions in its history. Toba was not the first. By the logic of geological time, it will not be the last. We are here. We built everything. We survived the worst the Earth could do. The Earth is not finished.